So today we are going to solve this problem, maximum subarray. So given an integer array nums, find the contiguous largest sum and return its sum. A subarray is a contiguous part of the array. So we need to return the largest sum in this given array, largest sum, and that sum should be of a subarray. We need to get the sum. We need to return the sum which is the largest sum. It should be a subarray sum. So the brute force approach is we need to generate all the subarrays and we need to get the sum. We need to compute the sum, and with what sum gives the maximum, that sum we should return. Another approach is a DP approach, which is a Cardenas algorithm. It will be a DP approach, and in this algorithm what we'll be doing is we'll be computing the sum from index from the starting index, and whenever the current number is greater than the sum, we'll make the sum as uh, the current number which is way more than the current sum, and by computing by traversing this for loop, we will be getting the maximum sum. This is a kind of a DP approach where previously it was we can use here the space complexity is of 1. There is no space complexity here of 1. So previously it is a DP approach. Here in this discussion we can see it as a DP approach. Here what I have done is computed the sums, and whenever the current number is greater than the sum, I will change the sum to the current number, because this current number is giving me the maximum sum, maximum subarray of length 1. It can give the maximum sum, so that's why I have made the sum as this nums of I, and I'll be updating the maximum in order to return the maximum sum. This is the Cardenas algorithm. Another approach is divide and conquer. In using divide and conquer, we can solve this problem. I have seen this YouTube video. I have seen this YouTube video in order to solve this. You can also see this YouTube link. So what in this divide conquer is happening is we will be dividing the array like a merge sort. Like in the merge sort, we will be dividing that array from middle parts, right? Like after the after dividing all the array, we will be merging, right? So we don't merge here. We kind of do we'll have a long here we have used LSS, RSS and CSS. It is a variable name, so you don't need to worry about this LSS, RSS and CSS. So here what we will be doing here, left LSS means left subarray sum. Okay, left subarray sum. RSS means right sum right subarray sum. Right subarray sum. CSS means center subarray sum. So here LSS left subarray sum is -2, right subarray sum is minus It will be left means, wait, let me see the code. Yes. Here mid will be same index. So when the same index, okay, okay, I got. Okay, when I the so when we got this same index, so when there is only single element, we'll be directly returning. So for this subarray, the LSS, the left subarray sum will be -2 and the right subarray sum which is -5. And this CSS, the center subarray sum, like this is some type of this is a computed sum from middle part. I will be showing here. The CSS here the center subarray sum is this part. So this part is the center subarray sum, which is -2 plus -5, which is -7. So we need to return the maximum from this LSS, RSS and CSS, which is center subarray sum. And next this return value will become the LSS for this subarray, and we will be after that we will be computing the right side part also. Here LSS for this subarray is 6 and RSS for this subarray is 4. It is not 4, actually it is -2. And the CSS 6 plus, okay, this is CSS. I made a mistake, actually I need to keep it in middle. Okay, 6 plus -2 is 4. This is the CSS and this is RSS and this is LSS, which is 6. Left subarray sum is 6 and right subarray sum is -2 and the center subarray sum is 4. So next here we came to here and we'll be returning the maximum from all this, because we need to have maximum sum subarray. So we'll be returning 6 as the from this right part we got 6 as the maximum sum. So 6 is returned as RSS, like a right subarray sum. And this is the left subarray sum. We got the -2 as maximum subarray sum from the left side. So this is LSS. And the middle part, how it is computed? It is computed from the middle, from this mid to towards the left it is computed, and the maximum is kept here. Here -5 is the maximum sum. -5 plus -2 is -7, which is less than -5. So we store only the maximum here, and this is the value which is computed from mid to left side. And now from we need to compute from mid plus 1, which is 2 to towards the right. We need to compute the sum with the maximum sum. So 6 plus 6 is the sum at mid plus 1. When we go towards the right, 6 plus -2, which is 4. 4 is less than 6. So we only require the maximum sum while going right. So 6 is placed here. When we add the left computed sum and the right maximum computed sum, left maximum computed sum will be the CSS. So CSS will be 1 minus 5 plus 6. This giving me the maximum sum when the CSS is computed. So here 1 is the CSS. So out of this, what is the maximum? Minus 2, minus 1, minus 6. 6 is the maximum. 6 is written as LSS for this entire array. So we also need to compute the right side part also. So this loop, the recursion will go like this, and when the base case hits, it will return the left subarray sum. Since only one element is there, it will directly return minus 3, and towards it will go towards right, mid plus 1 to right side. So here it will return 1 as the right subarray sum, and here the center subarray sum is minus 3 plus minus 1, minus 3 plus 1, which is minus 2. So minus 3 plus 1 minus 2. So here out of this, what is the maximum? 1 is the maximum subarray sum we can get. Like if we consider this array only, we get 1 as the maximum sum. So we'll be returning 1 as the LSS for this subarray, and we'll be computing similarly for the right side part also for this subarray. This LSS is 5. This is the LSS for this subarray, and this is the RSS means right subarray sum. Minus 6 is the right subarray sum, and center subarray sum. From the center, what is the maximum subarray we can get? 5 minus 6, which is minus 1, is the center subarray sum. So out of this, what is the maximum? Left subarray sum is giving me the maximum. That means 5 is giving me the maximum subarray sum. So this is becoming the RSS here. Here from the center, we need to compute left sum and then right sum. So here what we will do? We will be adding maximum sum towards the left. So when computing maximum sum towards the left, 1 is the maximum. 1 plus minus 3, which is giving me minus 2. Minus 2 is less than 1, so 1 is the maximum sum I am getting. So 5 plus minus 6. 5 is a sum towards the right, and 5 plus minus 6, which is minus 1. So minus 1 is the less than 5, right? So 5, we only consider 5. So 1 plus 5 is 6. So here 6 is written as RSS. So center subarray sum is giving me the maximum sum to here in this subarray, like a 1 5. So here similarly for this entire array, we need to compute center subarray sum. Since we got left subarray sum and right subarray sum, and we need to compute from the middle. So what is the middle? 0 plus 7 divided by 2, 2 3s are 6. So 3 will be the mid. From this mid, we will be getting the maximum sum by traversing like this. So minus 2 plus 6. Minus 2 is a minus 2. Minus 2 plus 6, 4. 4 is giving me the maximum sum. 4 minus 6, 4 minus 5. 4 minus 5 minus 1. 4 minus 1 minus 2 minus 3. So 4 is the maximum sum I am getting. So 4 plus next from mid plus 1, we need to traverse towards right. So this minus 3 plus 1, minus 3 plus 1 plus 5 is giving me the maximum. No more than that is giving me the maximum. Suppose if there is a one more element like 100 here, if there is a one more element 100, then this after adding this all, we'll be getting the sum maximum, right? That sum will be kept here. Suppose here 3 plus minus 3 plus 1, which is 4, 4 plus 5, 4 plus 5 9, 9 minus 6 4, 4 plus 100 104. So 104 I need to keep here if there is one more big element here. So maximum sum is kept here. So the maximum sum I got is 3. So 4 plus 3 is 7. So 7 is the maximum answer that we got in this problem, in this array. So 7 is the maximum sum. So 7 is the maximum sum. Here we can see the code for this. Here if I greater than j means it crossed the suppose this is I and this is j, so we don't have the subarray here, right? So this is crossing, so we need to return the minimum, because we need maximum subarray sum. So in order to this is the failure case, right? So for the failure case we have returned the minimum in order to return the maximum answer. When there is only single element, I will be returning only the array element, as previously I have returned only single element as the array element. So in that way we'll be returning only the single element here, and I will be computing the mid value, and LSS is traveled, like we'll be dividing this similarly this is like a merge sort. What we do, we divide that array, like we divide the array, like so in that way we'll be dividing. So after dividing this CSS, this part you will be knowing, but CSS is somewhat tricky. Like we will be traveling like towards the left, and we will be traveling towards the right. So this is making. So this process of making is somewhere. Um, so we need to compute. We need to get the maximum sum left side, maximum sum right side. This will be the right side end will be mid, and left side end will be I. So I have done this. I have explained for the left computation, like no, this is removed. So this is not there. Okay, instead of k minus minus. Okay. So when I and j are crossing each cross their indices, then I will return int min I will return, and sum will be from j. I will from j minus 1 I will be computing the sum, and the maximum sum, max sum is returned, max of. So here I have returned the wrong code, but I'll show you the in the lead code how I have returned. Max sum is returned here, max sum. Yeah, in the lead code I have solved this using a single function instead of using the double function. Like for computing left and right, I have used only the single function. So this is the code for this. So if they are, so this is starting from here. I will be computing getting the size of the nums and solving this. And in the solve function, what I have taken, when the I and j are crossing, I will be returning minimum. When the I is equal to j, means only single element is there, I will be returning the that element. And I will be computing the mid, and LSSR left subarray sum and right subarray sum is will be getting. And boolean left means this is for computing the left, for getting the maximum sum from the left side, and this is for getting the maximum sum towards the right side. Here I have passed it is not left, means it is right. Not left means right. Computing uh, computing towards right side. Okay, this is for computing the right side, and finally I will be returning the maximum from LSS, RSS, and RSS, CSS. So this is for uh, this is as I have explained here, the divide and conquer method. So we finally you need to understand is how we can compute this get maximum sum. Like we expand. Suppose this is the middle part for this array, right? So we go till the end and get the maximum sum by computing from here. So when the I and j are crossing, I will be returning minimum, and when there is only single element, I will be returning. Um, when there is only single element, what is the maximum sum we can get only that element, right? So that's why I have written that. So direction here, instead of using two functions, so what I have done is I have used a single function, right? So I need to know the direction, like for computing the left side, we need to move left side, right? Like minus one, k minus minus, like that we have used, right? So for that, for doing that, what I have used, I have declared the direction variable minus one. Left means minus one, right means plus one. So for sum also, for getting maximum left, from j we will be starting, right? So like for suppose if we when we want to compute this when we want to compute this left sum, this will be the I and this will be the j, right? So when the left part is computed, we will be computing from this j, and when this is left, the j will be j plus direction means j minus 1 will be starting from here to here. The for loop is executed from 2 to 0, and meanwhile the sum is computed, and maximum sum is stored in some variable, in maximum sum variable, and returning the maximum sum here. In this way we are going to get the maximum sum computing from the middle part. And the for right side and the for right side, it is nums of I. Nums of I means this. From for computing right side, this will be the range, right? This will be the I and this will be the j, as we are passing here. You can see uh, here getting maximum sum, this will be the I and this will be the j for this function. So for computing the right side, nums of I will be becoming the sum, and maximum sum will be the this sum, and I plus 1 means I plus 1 direction is 1 for moving right side, right? So I will be starting from this, in the for loop I will be starting from this 5. So this is the past I read, I have in k will be starting, like this for loop is starting from this 5. and I will be computing the sum is previously 3 minus 3 minus 3 plus 1, which is minus 2, again storing that in the maximum sum, and in this way we will be getting the maximum sum. And this is the executed code that I have previously submitted. I need to make it this comments. So this is the running code previously I have submitted. So that's it. This is a OAuth login, because we are using divide and conquer, and I have followed this YouTube video. If you want, you can see.